Alright, day 2 out here. Here's the new First Company fan coil that I'll be installing. And here's the evaporator coil. I shipped this evaporator coil to Minnesota to get it dipped. And it actually has they dip it into a big tank of paint. It gets deep into the fins. And then they pull it out of the tank and they bake it. See over here, it gets capped, it gets baked, then they actually, before they bake it, they blow it with air to get the paint deep inside of the fins, and then it takes a First Company warranty from 1 year to a coil that will last 20 years at least, because it'll never get corrosion on the copper, because nothing's ever going to touch the copper. So here I finished all the prep work on the unit, installed the coated coil on the bottom there, installed the expansion valve, hard soldered everything in, insulated it, also put in the overflow protection, which actually detects if the pan gets too high and shuts down the unit rather than overflowing to unit below. You can see the sensor for that down in the bottom, and it's on the back side of the pan where the water accumulates the highest. Right down there, it has 2 little probes, and if the water touches the probe, it turns on the red light and shuts down the unit. And rather than without a sensor like that, it'll just overflow, start flooding the floor, leaking to the bottom unit. I'll get you a side view. Right down there on the bottom. I silicone it in so it doesn't move. That way it stays where I put it. This unit has an electronic control for the hot water pump on the top. And what that does is it allows a post-purge of running the fan after the heat shuts off. And it also has a neat feature since this is domestic drinking water and hot water coil, this board can turn this pump on just for a minute. And I'm not sure what the time is. It might be once a week, and just to purge out so you don't get kind of like nasty tasting water on your hot water, from like all summer long when the heat never turns on. This will automatically just purge that water every so often to keep it fresh. Here's a piece of return air duct that I'll be using as a supply duct. And here's the work that I've already done on the return. This is the return plenum. It's lined on the inside. Turn some light on there. It's lined with fiberglass insulation, so that it reduces the sound. It also has a filter grill in it, and which the unit can take a filter also. And so you don't have to have it in the plenum, but this plenum already had the filter in it, so I'm going to leave it there. And but what they also, in the back of the grill, you can see I caulked a major air leak where air would go around the filter. And then I'm finding a lot on these top units that there's major leaks to the outside. There was a hole right next to the pipe, which I patched up behind the unit. That patch was all open wall. And the biggest issue that I find, actually 2 of the biggest, I took some video of this yesterday with my Palm. I'm using an old cell phone, but the video just wasn't very good to see. Here's that whole area above the ductwork was all open to the rafters, and that basically leaded directly to outside. Also, right here is another big air leak in this room, which is behind the electrical breaker box. They don't do the drywall because you can't see it, which is fine. You don't really need it, and but they left a big open spot, which is basically a 1/4 inch gap all the way down. and it just goes to the exterior, and you get some major drafts, which can come through there. Here's what I did on the return air. Since all the air is going to be coming from downstairs, it had an old return air which was only 8 inches round, which was only about half a ton, you know, practically nothing. I've enlarged it to a 16 by 25, and then the actual opening into the return air duct is 14 by 14, which is plenty to handle 3 ton. So you can get good airflow on the return side to the unit through the hallway here. And again, that lets me use the old return air for upstairs as a supply air to solve the cooling problem in the loft. Now here's the old return. You can see it goes up to the return air grill in the loft, which is, I'm going to turn to a supply grill. I don't know if you hear an echo. These sheet metal ducts make quite a bit of echo. So to make this grill quiet, I put some liner just like this. I'm going to glue that liner into there, and it doesn't take much. And this will be about 3 feet pieces of liner, and it makes it where the sound doesn't echo, and it also absorbs the sound from the fan. And this is what the altered ductwork looks like. Supply air tied right into the supply plenum, goes upstairs. I used the nice radius 90s, which were previously the return air. And then you look inside, you can see the opening. I have a just a manual damper that I can adjust if I need to. So this is the opening that goes to the loft. This is the opening which goes to the rest of the house, which previously was the loft also, and still is. But you can see I'm about 1/3 of the size of the entire ductwork area just dedicated to the loft. And so there's plenty of air, and if there's too much for some reason, I can reach in and just close this air scoop. I was checking out some of these elbows I'm actually reusing on the hot water, and that's what a bad solder joint looks like. Wasn't cleaned properly, and put a light in there. You can see the line. The solder only went to the line, and then see how the water, it was getting, you know, into right there. Almost got the water got to the point where it was leaking. You can see how close it is to the edge. About I think 3/16 of an inch. Not much solder holding the water back. That's just the joint wasn't cleaned properly. That's all. Here's a condenser unit that's getting changed out. It's a 2.5 ton, and it's actually not the original, it's newer, but it wasn't large enough to handle the upstairs condo, and so I'm changing it out to a 3 ton. You can see there I unsoldered the pipe, catch any solder in the pan, and you know, change out the unit like that. So the question is, how does one person take this unit down this hole and takes the new unit back up on a day that's slightly raining like today, and does it safely? Well, what you do is you double strap the unit, and so each strap, it can hold the unit by itself, but you got backup redundancy. You use an A-frame with an electric hoist. Electric hoist is rated 440 pounds. And then, most important, is use a backup just in case you got a problem with the hoist. I have to do a disclaimer here. I've done commercial marine in Houston on cargo ships for 2 years, repairing refrigeration, air conditioning systems, and this type of work requires experience. There are a lot of ways to get injured whenever you're lifting something more than 70 pounds, especially if it's lifting up more than a few feet. And but I'll show you the video how to do it safely. But this is the old roof. They don't require a crane, and so this method works fine. It takes a couple hours. Being rainy today, I'm not going to do anything else. Just wanted to swap the units out, and then I'm going to come back when it's not raining, hook up the piping and stuff. Two boards are secured where they don't move. These units are about 120 pounds. Yeah, a little bit heavy, but not too bad. Put the unit on the board. Go ahead and hook up for safety before I go over the hole. Use dead man's knot on the rope. The rope is going to be separate from the hoist. So either the hoist or the rope could fail, and the unit's still going to stay. Slide over. Lift the unit up. Now I'm always holding the backup rope in my hand. Ladder out of the way. So I'm going to hold the ladder out of the way. Backup rope works very well. I can actually hold this unit with one hand if I need to, but I have the hoist which holds it all the time. All right, the unit's down, and you can see I put it on. Actually, looks like it's on my jacket, but it's not on the carpet. That way the carpet stays clean. Now I just slide the ladder over, and I can safely go down. So strap up this unit here, and I'll hoist it up. These straps they're rated, I believe it's like 600 pounds each. You always want to have safety margin, you know, when lifting. 2 straps, each one can handle the unit. Hoist 440 pounds, the unit's about 140. We got plenty of margin on the hoist. Hook to both straps. That's why you gotta have experience doing this. Not for the weekend warrior. Dead man's knot again. Anybody else that lifts these units up without a crane, they're doing it by hand, I guarantee it. Not using a hoist. The problem doing it by hand is it just kills the back. You gotta have 2 guys with a rope on each side, and then you lift it up through the hole, or if they're really brave, 1 guy lifting it by himself. But I'm getting a little old for that, and plus I would never do that anyway on my back. Got to use it for the next job. All right, to hoist it up. And you still apply the backup rope while it's going up. Do have to guide it a little bit through the hole so I don't scratch the unit or scratch the hole. Once the unit is up, I put the support boards back. That'll hold the unit while I can move it off of the hole. And then lower onto the support. Now notice I'm still keeping it attached to the winch and the backup rope as I move it off of the hole, just as a backup. Now I got it off of the hole, I can just set it on the pad right there. I would change out the pad if this was the new roof, but they're going to be doing that already. So this unit is going to go on the old pad. Hopefully I'll be the one doing the disconnect when this flat roof gets done. I gave him a price. Roofer seemed to like me. Unit's a little bit heavier, but manageable. Oh, another safety tip. You know, if any of my competitors are going to be doing this, which I said I don't want them to do, but if they did, I had a bolt through here. It's real important that this winch is bolted to the ladder so it doesn't move sideways. Otherwise, you're going to be catching the ladder and in a hurry. And just a safety tip. Yeah, I wanted to show a couple things here. One is that this is a 3-ton Bryant unit, and the model number is 036. And notice it has 7/8 on the suction port, and existing in the wall is 5/8. So you know that's quite a big size difference there. It turns out, if you look up in the carrier literature, the performance penalty is 1% for a 20-foot run of having 5/8 pipe. So it's not a big penalty, and it provides, you know, essentially you get the full 3 tons, you know, through this size pipe, you know, without an issue. I also wanted to show, this is an indoor wire that's being used in an outdoor application. Notice it's starting to dry rot. And when I change out the unit, I go to exterior grade wire. I'm surprised the electrical inspector, you know, let that pass, but it's, you know, I see it quite a bit. You know, it's just a short piece of wire, like 2 feet, you know, to the box. And but we go with outdoor rated. It won't have a problem with the sunlight. I wanted to show the piping for the drain here. The drains are something that they look deceptively simple, and so secondary is capped off because we have the electronic overflow, you know, which will automatically shut down the unit, which generates the water. You don't need the secondary. The primary has slope down, slope again. You can see right there, it's always important to keep slope on the drain. And then it goes into the trap, which prevents from sucking. This is a suction part of the unit, prevents it from drawing in any sort of gases from the pipe. But looking from the side, notice how I have that slanted, and the water level for the trap will be right about here, and with the slant the water will run down the side, and you won't get any noise inside the condo of hearing the drain leak, particularly when the unit shuts off. You won't get that sound of running water because of the slant right here. So, and then it just goes down into the main drains for all 4 condo units. Another thing which I always do on the drains is I make them real easy to clean. Just basically take off this cap. The drain has access because here's where it clogs up, and then I connect a water hose up to the water, you know, right there on the furnace. Just give it a blast of water by putting the hose. Yeah, putting the hose in there, give it a blast of water, cleans out the drain. It just takes a second to do, and it can never clog up here because it has slope and doesn't accumulate any of the mildew. Also, notice how I move the drain out of the way, and it gives a nice space. Since the return air has been turned to a supply air, you get a nice space here in the closet, and without having to worry about the drain, you can put vacuum cleaner in there. Now I finished downstairs, I've finished on the roof, and I'm in the loft now. And what we need to do is, this is actually now going to be a supply air rather than a return air, and I need to convert this grill to this grill, so 14x6, because this is directional, and I'll actually direct it to the center of the loft. So inside the return grill in the loft, I got a nice 8x8 duct, and which I'm going to modify that to make it to the supply vent. I want to show a nice tool here for cutting drywall. It's an electric reciprocating saw. I use this saw in combination with this vacuum cleaner down here, and almost zero dust doing the drywall work, because I'm going to have to take out the drywall above and to put the vent in. Alright, I just want to show how I can cut this drywall without making much dust. Put on the vacuum, grab the saw. It's a battery operated saw. I do all my own drywall work. Comes in handy. Now, all I gotta do is take this piece out and then do the modifications to turn it to a supply vent. And then while I have it out, I can clean it also. I'm going to change this box to a 14 by 6 rather than a 14 by 14. Okay, now notice I finished the sheet metal, turning the upstairs loft return to a supply, and had to make a little extension here. Notice everything's caulked and sealed. There's the 6 by 14 supply. It's at the top of the ceiling. That way I can direct the air to the middle of the loft. And now I just gotta sheetrock it in. So now the loft supply is sheetrocked in and it's ready for mud. Alright, I want to show the airflow on the unit. The return air opening is 14 by 14, just in one place. So basically I read the air velocity, and in here you can see the CFM. It's about 1250, and I want 400 CFM per ton, which is 1200, and so I'm getting actually a little bit better airflow of close to 1300. Okay, I wanted to show airflow on the existing loft vents. So we got like 70 CFM on this vent. Okay, on this other loft vent, we got 76 CFM. Check it on both sides. Actually 100. We got 100 CFM on a loft vent. Remember, 400 CFM is 1 ton. On a new loft vent, the airflow is 380 CFM, essentially 400. So we've taken the loft from 200 previously to a total of 600 CFM now. That's tripling the airflow to the loft. I want to show how this overflow safety works. And so I'm going to fill up the pan with water, and then I'm going to plug the drain here so that the pan gets full. And then once the water reaches too high, the overflow device lights the red LED, and then it shuts down the unit. So here's the return. It's enlarged to handle the 3 ton. The extra vent is finished. The drywall is finished. It used to be the return. Turn that to a supply vent. The supply vent blows 3 times as much air as the 2 old supply vents for the loft. So actually, on a day like today, which is about 80 outside, the loft's actually cooler than downstairs because there's so much air going up here. And then in the wintertime, just close off that vent, and then the heat, you get the heat from the sun in the winter, and in summertime open the vent up, and then you get all the air you need in the loft. The drywall turned out well.